Hello, fourth grade. This is Miss K, and we're on lesson 10 of our Unit 5. We touched on this last lesson, but we're going to dive a little bit deeper and talk about weathering and erosion. So here is your vocab. Expand is a verb, and that means to get bigger. Contract is the opposite, so it's a verb that means to get smaller or to shrink. Ultimately is an adverb. See that ly telling us it's an adverb. That means finally or at the end of a process. Pepper, this is not the pepper that you put on your food. This is the verb pepper, and that means to sprinkle or cover. Deposit is a verb, to put or leave something in a certain place, and it can also be material that's left in a certain spot. Number 6 is state, which is a noun, and that is the condition of being a solid, liquid, or gas. So we talked about states of matter. A silt is a noun, and that is very small sediments that are moved by water. And then a canyon is a noun, and that is a deep valley with steep sides and often a stream or river flowing through. And here are two words that it's helping us pronounce. So we've got Yunnan and Shilin. All right, chapter 7, Earth's powerful forces of change. Our big question is, how do weathering and erosion continually, that means over and over, reshape Earth's surface? Have you ever dodged a pothole while riding your bike or skidded on grit that rain had washed in your path? Potholes and grit might seem like little more than bike riding hazards, yet they are evidence of two powerful forces at work. Weathering and erosion, as you read in chapter 6, are processes that drive the rock cycle. They break down rock into sediments and then move them to new locations. Together, weathering and erosion are slowly but steadily reshaping Earth's surface. They are changing everything from the streets in the neighborhoods and towns to the world's tallest mountains. Weathering at work. Weathering breaks rock into smaller pieces. Some of these tiny pieces combine with once living material to form topsoil. Other small pieces of rock collect as sediments. This breakdown of rock happens as they interact with air, water, and living things. There are two basic types of weathering: physical weathering and chemical weathering. Physical weathering breaks big rocks into smaller ones without changing the minerals they contain. Widely swinging temperatures cause physical weathering. For example, rocks in a desert bake during the day beneath the sun's scorching heat. As rocks get hot, they expand. At night, temperatures in the desert fall. As rocks cool down, they contract or shrink slightly. Expand, contract, expand, contract. This endless cycle gradually causes the rock's outer layer to crumble or flake off. Water also causes physical weathering. Water seeps into tiny cracks in rocks. If temperatures drop below freezing, the water turns to ice. Water expands as it freezes, pushing outward and enlarging the cracks. Geologists call this process ice wedging. Each time the water freezes, it opens the crack a little wider, and eventually the rocks split apart. Ice wedging is what makes potholes in streets too. Plants and animals also cause rocks to weather. Tree roots squeeze into the cracks in rocks. As the roots grow, they act like wedges, forcing the cracks wider and wider. Eventually, the rocks break apart. Badgers, chipmunks, and other animals burrow into cliffs and hillsides like tiny bulldozers. As they dig or tunnel into the ground, they push buried rock to the surface where most weathering takes place. So this is showing the cracks in the rock that can be caused. This is showing the roots causing crack in the rocks. It's growing through the rock. And then this is an animal that's burrowing through it and pushing that rock to the surface. So that was physical weathering. Think physical, it's changing its appearance. It's changing how it looks. It's not changing the actual rock. It's just breaking it, making it smaller, making it bigger. Now we're going to talk about chemical weathering, which breaks down rocks by changing the minerals they contain. Rain is a powerful chemical weathering force. As rain falls, it mixes with the gas carbon dioxide in the air. The result is acid rain. Acid rain is strong enough to dissolve some minerals in rocks. Once dissolved, the minerals easily wash away, weakening the rock. Acid rain very slowly carves some rocks into different shapes. It gradually erases the lettering on old gravestones and blurs the faces of stone statues. It eats away at the outside of ancient and even modern buildings. Where rain seeps into the ground, carbonic acid causes weathering of buried rocks as well. Over long periods of time, this often unobserved weathering creates caves deep underground. That's showing the the chemical weathering. So it's changing the chemical makeup. It's changing the minerals that make up the rock. Another gas in the air, oxygen, causes chemical weathering in rocks. With a little help from water, oxygen reacts with iron-containing minerals. The reaction changes the minerals, making the rocks brittle and crumbly, and turning them a rusty red color. Some plants release rock weathering substances. Take a peek under a patch of moss growing on a rock, and you'll see tiny pits in the rock surface. Acid from the moss plant caused the damage. As a result of all weathering, rocks are broken down into smaller pieces and ultimately into sediments. Erosion is what gets those sediments moving. So this is a towering rock formation that's created by chemical weathering. And this is in China. It says some formations are tall as a 10-story building, and this is called the Shilin or the stone forest. So these different shapes were made by chemical weathering. So acid rain or chemicals from plants cause the rocks to change. Sediments on the move. Geologists describe erosion as any process or force that moves sediments to new locations. Wind, flowing water, moving ice, and gravity all transport sediments from place to place. These forces are the primary causes of erosion. Have you ever stood on a sandy beach on a windy day? Did you notice that gusts of wind sent sand flying past? When air moves quickly across the ground, it picks up sediments and carries them away. Powerful winds can carry sediments for hundreds, even thousands of miles. On the windy beach, did your skin sting as it was struck by blowing sand? Wind carrying sediments can act like a sand blasting machine to wear away rocks in its path. So this is showing how the sand, when it's carried by the wind, it can actually break down those rocks that they hit. And this is in Arches National Park in Utah. When wind-driven sand hits rock, it chips off tiny pieces. The wind then whisks the pieces away. Over time, this form of weathering can polish rock surfaces or pepper them with tiny holes. It can shape huge blocks of rock into delicate stone arches and lofty towers. Weathering and wind erosion can also leave massive boulders balanced on slim supports. Have you seen wind-carved rocks look like this? As wind slows down, the sediments it carries falls back to earth. They are deposited on land or in water. Where wind deposits sediments regularly, layers of sediment slowly build up, and over time, those layers may be transformed into sedimentary rock. So you can see the arch here that was created by the wind, by erosion. It says glaciers like this one in Alaska are powerful forces that can cause erosion. So here's the glacier. You can see the erosion that it caused. Like wind, water also causes erosion. The tug of gravity pulls sediments out of wind and water. Flowing water picks up sediments and carries them downhill to new locations. A summer rain can wash fine sediments into sidewalks and into gutters. A rushing mountain stream can sweep small stones into a valley. A flooded river can surge along with enough force to move large rocks many miles downstream. As moving water slows, sediments sink to the bottom of the river or stream. The heaviest sediments are the first to be deposited. The finest sediments are the last. Layers of sediment accumulate at the mouths of rivers and on the bottoms of lakes. Vast layers of sediment are also deposited on the ocean floor over long periods of time. Like wind-deposited sediments, those laid down by water may someday be transformed into sedimentary rock. Water doesn't have to be in its liquid state to erode sediments. Glaciers are enormous masses of ice found in polar regions and near the top of tall mountains. Although ice is solid, glaciers do move. They flow very, very slowly downhill. As countless tons of ice creep over land or down mountainsides, they push, drag, and carry eroded sediments along. Moving glaciers also create sediments as they grind against rocks beside or below them. Glaciers are such powerful forces that they can carve huge U-shaped valleys through mountain ranges. When glaciers melt, they deposit the sediments that they have been carrying. About 20,000 years ago, glaciers covered large parts of North America, Europe, and Asia. As the climate warmed, the glaciers melted and retreated northward. They left behind massive deposits of sand, gravel, and silt, along with collections of rocks and boulders. You can still see these deposits as hills, mounds, and ridges on the landscape. Weathering and erosion work slowly. It takes a long time to see their effects. Given time, these processes reshape Earth's surface on a scale so large it's almost impossible to grasp. For example, the Grand Canyon in the southwestern United States did not exist when dinosaurs roamed North America. Wind, rain, and the Colorado River slowly created it. These forces cut and shaped the landscape into what it is today, one of the world's largest canyons. Millions of years ago, the Appalachian Mountains in eastern North America were a towering mountain range. The highest peaks might have been more than 20,000 feet above sea level. Weathering and erosion gradually wore the Appalachians down. Their highest point today is just 6,684 feet high. As permanent as mountains seem, weathering and erosion inevitably change them. Even Earth's tallest peaks, Everest in Asia, Aconcagua in South America, Africa's Kilimanjaro, and Europe's Mont Blanc, won't last. They will eventually be worn down by these endless geological processes, but don't worry, other geological processes are creating new mountains to take their place. Okay, a long chapter today. Number 1, topsoil and sediments are the result of blank, which is an example of physical weathering. Number physical, which is an example of chemical weathering. How are chemical and physical weathering similar? And then type in one reason that makes them different. True or false, wind also causes weathering and erosion. Sedimentary rocks are made up of blank. The text explains that the effects of weathering and erosion take place over time. So is weathering and erosion happening quickly or slowly? 9, flowing water causes erosion. 10, glaciers cause erosion. And 11, which is not an example of weathering, on pages 70 and 71. All right, I'm going to give you a separate video for your skills lesson because we have our spelling assessment today, so I will see you over there. Bye, Adams.